Hello Math 152 students. In this video we're going to take a look at one last example out of section 10.3. At the end of this example we will contrast the concept of statistical significance and practical significance. It's kind of a mouthful there, and try to understand what we mean with these two ideas. But let's just go ahead and jump in our example and we'll worry about those terms at the end. They tell us that in 2003, the average age of a mother at the first time of her childbirth was 25.2. To determine if the average age is increased, a random sample of 1,200 mothers is taken and is found to have a sample mean age of 25.5 with a standard deviation of 4.8. Determine whether the mean age has increased using a significance level of alpha equals 0.05. So notice here, we're going to have an increased situation for our alternative claim. This is actually the first time for 10.3 that we haven't had a two-tailed test. The other thing that's different is they're giving us summarized data and not the raw data. Notice, however, that this is a large sample size, much larger than 30, so we're going to be able to proceed without having to check anything. And in fact, without the raw data, you can't create a box plot and a QQ plot. So sometimes if you have a small data set and a summary, they might tell you something about those conditions, or they might tell you something about the underlying distribution. But you're more likely to have this scenario where you have summarized data for a large data set. Another way to think about this is for large data sets, it's kind of cumbersome to list them all out in StatCrunch, so it makes better sense to give you a summary. So let's go ahead and look at our setup. Here, we said that this is going to be a greater than scenario. If nothing has changed from our 2003, the average age would still be 25.2. Keep in mind, your null always has the equals, and the claim that we're trying to support is that the average age has increased. In other words, determine whether the average age has increased. So your alternative is the claim that you're trying to gather support for. In this case, we're trying to say that our mean is greater than 25.2. They specified our level of significance, so we know that's 0.05. Step 3, we're ready to get our p-value. So I deleted our p-value just so we could go through and verify it together. And let's go to StatCrunch and just kind of compare what happens. So notice this is my data set from the last example. We really don't need this. But if we go into our stat and our t-stats, we're still in one sample, but this time we have summary. So notice the information we have to fill in is sample size, mean, and standard deviation. So our sample size was the 1,200. And let's go back here. We have 25.5 for our mean and 4.8 for our standard deviation. All right, so we'll look carefully at this. Double check. Okay, so our numbers look good. The only thing left that we need to do is make sure we adjust our numbers in our null and alternative. So we were trying to compare and see if our mean was greater than the 25.2 that we saw in 2003, or if we were greater. So here, I'm just pulling the prior value, and that becomes the mean in my null. Then, there's no other options, no plot options, and we can go ahead and compute. So notice they just kind of repeat this sample mean. They calculate the standard error, which is incorporating our sample size. We're dividing by that square root of n in order to get this. And then notice they give us the t-statistic. We can think about this as interpreting the number of standard deviations that our sample mean is above the prior value of 25.2, and then also a p-value. So let's think about this test statistic first. This is telling us that 25.2 is a little bit over 2 standard deviations above the mean if we're expecting the mean to be 25.2. So even though there's not that much difference between 25.5 and 25.2, the standard error is small enough that the difference is actually 2 standard deviations. That's quite significant. And when we look at our p-value, the chance that we would see 25.5 or even higher when we're expecting 25.2 is rather low because that 25.5 is 2 standard deviations, actually a little bit above that mean. So notice this is smaller than our alpha of 0.05. So let's go back in and fill that in. Got those decimals right there. So what we want to say is that because the p-value is less than the level of significance, we reject the null hypothesis. Another way to phrase this is that we reject the null and we accept the alternative. So let's add that in. Instead of saying accept the alternative, we could also say there is evidence to support the alternative. Okay, so what that means is we want to phrase our answer in everyday language in step 5. So we could say something like there's sufficient evidence at the 0.05 level of significance to conclude that the mean age of a mother at the time of her first childbirth is greater than 25.2. Okay, so what does this mean? This means we are supporting the researcher's claim or supporting the claim that the mean age has increased. Whenever we have a small p-value, smaller than our alpha, and we reject the null and support the alternative, that is considered statistically significant. So sometimes you'll hear the term, this result has statistical significance. What that's telling you is there is a small p-value that allowed you to reject the null and support the alternative. In other words, the hypothesis test supported the researcher's claim, which is the alternative hypothesis. However, this is a little different than the idea of practical significance. Practical significance is the idea of, well, does it really matter? So in this case, we had statistical significance with a low p-value and actually demonstrating that the mean age had increased. But notice that the sample mean of 25.5 is not that much higher than 25.2. In other words, that might ask us, hey, is this result practically significant? So let's look at the definition just to recap that concept here. Practical significance that refers to the idea that while small differences between the statistic and the parameter stated in the null hypothesis are statistically significant, keep in mind that term means we had a low p-value, the difference may not be large enough to cause concern or be considered important. In other words, increasing 0.3 years in average age for first childbirth is probably not going to be making the front page of the papers or the news, right? In other words, this probably isn't a big deal that we saw a small increase in age. It wasn't even half of a year, so it may not lead researchers to really do anything different or make any different recommendations if this were part of a larger project or larger report. So I would say that this example gave us statistical significance, a low p-value, but not practical significance. So another way to think about it, when a large sample size is used in a hypothesis test, the results could be statistically significant even though the difference is not practically significant. Okay, so abbreviated a little bit though. So the results could be statistically significant even though the difference between the sample statistic and the mean state of the null hypothesis may have no practical significance. In other words, you can have a low p-value, support the hypothesis you were trying to support, and it not really be all that meaningful. Okay, so this is pointing out that the most common place that this can happen is a really large sample size. A large sample size means that when we go to StatCrunch, we're going to see a small standard error, and a small standard error means that the difference between the sample mean and the mean in the null hypothesis is going to have a large t-value or a large test statistic. And then a large test statistic is going to generate a small p-value. So keep in mind that this happens, and especially if you're looking at project data where you are getting a small p-value and supporting your hypothesis, you always want to ask yourself, do I have practical significance here? So let's go back to this final slide. Just reiterates the point that we were making that large sample sizes can lead to statistically significant results, while the difference between the statistic and parameter is not enough to be considered practically significant. So keep this in mind. We'll see this a little bit as we go through different scenarios, and you want to be aware of it in sort of your project scenarios as well.